In this video, we're going to talk about some basic network protocols. I am specifically going to use Cisco Packet Tracer. It is free of cost. You just have to register if you want on the Academy of Cisco, NetCAD Academy, and you can download it. Anyways, network protocols. I'm just going to show these definitions here, but I'm not going to read them like a professor. I'm just going to explain them. So these are rules and regulations which your PC use to communicate over network. Some of the famous ones are like HTTP, TCP, and UDP. They serve different purposes, but their ultimate objective is a safe and secure uh, and a way to establish communication between devices in a network. So every type of communication over the internet, it is governed by network protocols. IP address is one of the network protocols. It is a address of your device on a network. Usually, your router is the one which distributes IP addresses, and you may have seen it somewhere as something like a number in four sections, like 192.168.1.1, something like that. So there were, let's say there were two devices, device A, computer A, PC A, whatever, and computer B, and they're connected by a physical uh, way of transport, physical way of communication, and Ethernet cable in this case. Now, although they are connected physically, there is no way for them to communicate unless they have an IP address. So let's say the IP address of A is X1 and of B is X2. Now the device A knows that if I'm going to send a message, I'm going to send a message to X2. It is going to use the address of the device B to send it. There are two types of IP addresses, IPv4 and IPv6. IPv4, I mentioned earlier as well, it is something like this, 192.168.1.1. It has 4 octets. That's why it's called IPv4. You see 1, 2, 3, and 4. Like every digits, numbers inside the dot, they are counted as 1 octet. And every octet has 8 bits. So 8 bits time 4 octets. 8 times 4, it's 32. IPv4 therefore is often called as 32 bits network address. And on the other hand, IPv6 is considered 128 bits IP address because it has more octets and every octet is carrying more bits. So here is Cisco Packet Tracer. I'm just going to simply place two PCs as I showed you in the example. I'm going to connect them with the Ethernet cable, and I'm going to attribute an IP address to them. I'm going to select the interface. Interface means where that cable is connected, and let's say PC0 is 1.2, and let the PC1 be 1 point something like 1.3. Okay. Now both of these PCs have address, and that means they can talk to each other. How are we going to test it? We are going to use the ping command. Ping command, it's basically just like it's like a message. Your device sends out a message on the network asking about the other device. It just sends like a packet. We are going to talk about network packets as well in the future videos, hopefully. So it sends a message over the network to the address you want to send, asking, like, it literally doesn't ask like that, but that's what it does. It asks, hey, are you there? And then the PC replies that yes, I'm there. So ping, it's just a way to check connectivity. You will be amazed how much ping command is used in professional environments. No matter what we're configuring, we're always using ping commands. So let's go to the command prompt of this virtual PC and type ping, the address of the first PC, 192.168.1.2. Hit enter, and you see I'm getting reply from the PC0. I sent 4 packets and I received 4 packets. I sent my request, hello, is anyone there, 4 times, and the other PC replied 4 times. That means the connection is established, it's perfect. I'm able to communicate with the other device over the network. Besides that, let's talk about static IP address and dynamic IP address. There are two main types of IP addresses. Static IP address, it means that we are going to allocate IP address to a device. That's the one which we did right now in Cisco Packet Tracer. We attributed an IP address to the system. We defined it ourselves. And then there is dynamic IP. Dynamic IP, usually it is done by the server or by your router. Both of them nowadays have, your routers nowadays, they have built-in facility to distribute IP addresses. So it's like a central device, a server router, and it automatically distributes IP addresses to the connected devices on its network. And your Wi-Fi, it's dynamic. You connect your Wi-Fi, your router automatically gives an IP address. So DHCP, it means Dynamic Host Control Protocol. This is the protocol which literally manages the allocation of dynamic IP addresses. Uh, DHCP service can be in a server, or it can be in a router, or in some cases it can be in the switch as well. So, or VPNs as well, if you have configured a professional VPN like MikroTik or something like that. So it also has the DHCP services. Technically, VPN is a router. So DHCP is what distributes your IP address when you connect to a server. Your network, your system, sorry, your computer asks on the network, is there IP distributed on this network? And if there is your server, it distributes the IP address. Here you see I have placed the server and I've removed the IP addresses of the PCs which we attributed before. I'm going to configure the server. Let IPv4 address of the server be 1.1. That's why I left 1.1 before, if you remember, because I saved it for the server. Usually that's how it works in professional environments. So here you see I'm verifying default gateway. Another important concept. Default gateway means your network from where the traffic is going to be transmitted. So for now, you don't have to worry about it. For now, let our default gateway be the server. All the traffic of our network is going to be transported by the server. And then let the DNS server be our server as well. Like our server is the one which is the DNS server and the DHCP server. I'm going to talk about DNS in a while. So everything is configured here. And DNS, yeah, as I mentioned. DNS stands for Domain Name System. It's like a phone book. It's like literally a translator. You see, if when you search youtube.com or google.com or anything, you basically are searching in words. But computer, as we discussed earlier, works with IP address. So your computer has no idea what is youtube.com unless the DNS translates youtube.com into its relevant IP address. So although you are searching youtube.com, your system is not communicating with YouTube's server via the name youtube.com, but it communicates with YouTube by its IP address. So coming back to our server, let's configure DNS. First of all, yeah, DHCP, sorry. So let default gateway be the server again, 1.1. The DNS server is our actual server once again. It can be different as well, but for now, let's keep the video short. Start IP address, it means from where I have to start. I want to start the distribution of the IP addresses. So I'm going to make it 51. Let's, just to check something to see how it's working. Turn on the service. Usually the interface of DHCP configuration is always the same. There are just like few things up and down. So DNS, let's say I have a website named networks.com, and let's say its public address, IP address is this. Yeah, sorry, I had to select it. Yeah, here you go. Networks.com is the website, and there is its IP address. Let's just create another website like Night Soul. Okay, there's my YouTube channel. nightsoul.learn. Okay, and let's attribute some IP address. Just random gibberish, doesn't matter, but I don't think it's going to work. Yeah, I knew it. Yeah, let me just come up with some like imaginary IP address. Okay, maybe that 365 is making the problem. Let me just remove 365 as well. Yeah, let's just keep it simple. Yeah, we often get tangled. Yeah. Anyways, okay. We have two websites configured now. Websites are the name, domain names, and their public IP address. And now let's make a general test. Here's my desktop. I'm going in my PC3, and I'm going to select DHCP. I requested on the network. I want IP address and the server distributed the IP addresses alongside other services which it has, like DNS and gateway. So again, on PC1, I did the same. Instead of allocating IP address, I selected DHCP, dynamic host control. Let's try to ping the server from this PC, and you see the network is fully established. My request went from the switch, then it went to the server. Let's see the DNS. nslookup is the command we use. nightsol.learn. Let's see what is the IP address of nightsol.learn. Oh yeah, I forgot to turn the service on. Yeah, that happens. It's pretty normal. I'm not going to cut this part out. Let's just be honest. Okay, nslookup. ipconfig before that, yeah, to verify if you are receiving IP address and everything from the server. It is also very daily used command. Now we can do nslookup and nightsol.learn. Here you go. I searched nightsol.learn, but my server translated the IP address, translated the name into the IP address. That's literally what the DNS does. So the second website, it was not named learn.com. It was, I think, networks.com. Oh yeah, it was networks.com. Yeah. So the result is going to be the same. There's nothing different, but let's just do it for the sake of the video. nslookup networks.com. Here we go. Here we have the public IP address of the website of networks.com. By the way, all of this works in real life as well. Here I'm going to open my command prompt. I'm going to type ping. I'm going to ping my router. Here you go. I can ping my router, which means my router is on the network. It accepted my ping. It sent a reply to me, of course, in ping. Let's see nslookup youtube.com. That's what I'm going to search, youtube.com. But the server which is going to provide me the facilities of YouTube, this is the address of that server. See, the public IP address. Similarly, you can try something else, let it be nslookup wikipedia.com. And you see here's the public IP of the Wikipedia. Anyways, thank you for watching the video, and I hope you liked it. Please leave a like and comment, and stay tuned. Thank you.